Hey everyone, I've gotten a couple of questions on simplifying complex rational expressions, so I thought I'd go to the board, work an example for you guys, and see if we can get the answer here. So I pulled an example off of MAT134. I believe this is question 26 or 27 from the homework. You can double check that, but basically what we're given is we're given 1 minus 64y squared over x squared over 5 plus 40y over x. So one thing that we want to keep in mind is that we always have to adjust our numerators and denominators by values of 1. So if I multiply by some form of 1 at the top, I have to multiply by some form of 1 at the bottom, make sure that I don't change the overall balance of our equation. So the way we're going to do that is we're going to approach this using least common denominators. So what we're going to do is we're going to look at the denominator for our denominator for our numerator, which is kind of weird to say, and then our denominator for our denominator, because we're nesting a denominator, or excuse me, nesting a fraction in a fraction, nesting a fraction in a fraction here. So what we see is we have a denominator of x squared and a denominator of x. Obviously, the least common denominator for x and x squared is x squared. So what we end up doing is we're going to multiply the top by x squared and the bottom by x squared. And the reason we can do that is because x squared divided by x squared is equal to 1. So if I multiply the top by x squared, well, I get x squared minus 64y squared. If I multiply the denominator by this, well, in this case, I don't cancel out completely. So what I get is I get 5x squared, that's part easy, 5 times x squared, but I get x squared over x, so I'm left with 1x still. So I have 40xy. That's a little messy, so let's see if I can rewrite that. Go back a little, let's see if I can. Plus 40xy. Okay, so this is what we are now left with. So for us to now simplify this, we need to recognize a couple of things. First of all, I need to recognize that I have a GCF here, and I have a difference of squares in my numerator. X squared minus 64y squared is a difference of squares, and it's going to factor into 8, or excuse me, 8. I'm jumping ahead of myself. It's going to factor into x minus 8 times x plus 8. Okay, that's easy. Now, for my denominator, I'm going to factor out my 5x. That, of course, leaves just an x in here. And we've got 40 divided by 5 is 8. So we've got positive 8y. And for those of you watching at home, you probably caught this mistake that this is supposed to be x minus 8y and x plus 8y. Don't forget about this y squared here, the way I did. It's very easy to make a mistake, but we were able to catch it. So we've got this fraction here. We've got x plus 8y, x plus 8y. We find out that we can cancel those out. So this now simplifies, and I'll put it down here at the bottom. X minus 8y over 5x. And we should be able to check that answer, so let me see if I can get this pulled up. So here is the example that I'm working from MAT134. So we had our answer that we came up with was x minus 8y over 5x. So x minus 8y over 5x. So I have x minus 8y. Selecting everything, letting it know that I want to do division, x minus 8y over 5x. We should be able to check our answers. Fantastic, we got the great job. If you go through the view and example, you'll see that this is called the least common denominator for the entire fraction, and they walk through the same stuff. It's a lot of text, but the denominators again are x and x squared, which therefore makes our LCD of x squared. Multiply everything by that denominator, x squared over x squared, not changing the value of our problem. Then we have to simplify, use the rules we learned from last week, cancel out any terms, and we should get our answer. So that's hopefully what you saw walked through in this video, but if you have any questions or concerns, please let me know.